Hello everyone. Today I'm going to introduce you to machine learning in Swift. Okay, so today I'll be covering two things like how to integrate machine learning model, uh, already trained model uh, on a device using CoreML, and how to create a model and train a model for object detection and analyzing images using CreateML framework. Okay, so let's begin. Now, what is CoreML? CoreML is Apple's machine learning framework to integrate already trained model in iOS uh, app. Sorry, it was first introduced in iOS 11. It is used to integrate model trained machine learning model in the app. So it supports iOS, macOS, tvOS, and watchOS. So these are the applications of CoreML, uh, like analyzing images, face detection, next word predictions, like you must have seen in while typing email and some messages, like next word comes like, so it is the machine learning model, so that is predicting the word, and speech for converting audio to text, and sound analysis for identifying sounds in the audio. So where Apple uses machine learning? So Apple uses machine learning in the Photos app to detect people, keyboard, as I said, for next word prediction, in Apple Watches for handwriting detection and heart rate. As you know, the Apple Watch is known to detect abnormal heart rate with 95% accuracy. Like also, it can send SOS signal if you met with an accident. Okay, so this is the core ML architecture. Core ML is built on top of Accelerate and BNNS. Of Accelerate and BNNS are frameworks of these are Apple frameworks, and Metal performance shaders for graphics. Also, it supports vision for analyzing images, natural language processing for text, speech for converting audio to text, and sound analysis for identifying sounds in audio. So, what are the advantages of CoreML? Okay, it can run locally. It is easy to integrate with the app. Data privacy, as it is offline, is not connected to network. It gives privacy. Real-time machine learning with low latency, and compatibility with other popular ML models. And what are the disadvantages? The It increases the size of your app. Uh, the power consumption is more, and it supports limited number of model types, because if there is a model like TensorFlow model like level 6 with level 6 tensor, it will not support that. So it should be less than 6, and training of the model cannot be done in core ML, so there is a separate framework for that. Okay, now how to get a machine learning model? So there are different ways to get a machine learning model. Either you can use existing pre-trained core ML models with the .ml model file extension, or you can use pre-trained open source models and convert them to core ML model. Okay, and other options are like you collect data, train using the create ML framework, This will see in the upcoming slides how to train the model, and you will get a core ML model. And other option is collect data, train using open source libraries, and convert that model into core ML model and use inside the app. Okay, so this is how you get a core ML model. Like these are the libraries used to create ML models. So you can create ML models with these libraries, and you can use a tool called CoreML tools to convert that into ML model, because the CoreML tools is built in Python and C++, and then you can use that model in CoreML. So create ML, we'll go to create ML. Uh, create ML is app used for building and training core ML models. It was first introduced in 2018 as a framework, and later Apple came up with a dedicated app to train the machine to create and train machine learning models. Okay, so these are the create ML features. Uh, you can train like multiple different data sets organized in a single project. Having full control over training, you can like pause, save, resume, extend your training time, use eGPU, that is the external GPU support for faster trainings, and preview the test, like preview the training outcome directly in your app without any need to use Xcode. You can preview model performance with this continuity, which allows you to use your iPhone camera and microphone on the Mac, or by adding sample data. You can drag and drop uh, okay, so these are the supported model types. So uh, it supports models like for computer vision, sound and text. You can create models for image classification, object detection, as well as styles transfer and action classification. Using motion sensor, uh, you can also create classification models. Uh, it also used to classify sounds or text, as well as create regression and recommendation models. Okay. Okay. Now, how to build models with CreateML? Okay. To build models, first you need data, and then some algorithm, and to convert that into ML model. So I'll show you practically how to do it. So this is our Create ML app. You can either open it from directly from the Spotlight search, or go to Xcode and developer tools and open Create ML. Create a new document.
But we are just seeing the slide.
Okay, just hold on.
Uh, you can stop share and reshare again.
Okay, can you see my screen?
Yeah.
Okay. So this is a create ML. So you can create a lot of machine learning models like image classification, object detection, like all this. So I'm selecting image classification. I have to create next. Give it a name like image. So after creating the project, you will see the screen. Okay, I already have downloaded data. Is there any option to share the whole desktop? Like I can share, I can see it like I can share it by parts. Like
Yeah, you can select by control and then select the tabs or parts, then you can share.
okay, share, Control N. Okay. So can you see the screen? Okay, so I already have some downloaded data uh, in this. As you can see, I have images of apples. I have downloaded these images of apples, bananas, and mangoes. So I'll be training the model to recognize these uh, images. Okay. So what I'll do is I'll drag and drop this folder in this create ML. So it says, and there are 3 classes and 84 items total it recognized. So I am setting default iterations as 25. So this you can set. And so if you want to train for 5 classes, uh, the the minimum number of items that Apple recommends is 10. You can set 10 images of each class. Like if you want to say like I'm training 3 classes like apple, bananas, and mangoes. So minimum 10 I should have. So I cannot have like 100 items of one class, 10 items of another class, and like some any other like random number of other class. So all that should be trained equally so that to get better results. So after this, I'm like training it by clicking train. So it has started training, and it has also finished training, and it has a training accuracy of 100% and validation accuracy of 80%. So, so this is the output I get. So this is a demo image classifier, what I get. And I go to predictions. What it expects is the image of 299 by 299, and it will output data. So this is a dictionary it returns, like it will return probability like of each class, and if it is most likely, if it is most likely a image category, then it will return a class label. Okay, so let's preview what we have trained. So what I'll do is I'll drag and drop one image here to see if it recognizes it or not. Okay, so I have downloaded some images. uh, let's say I'll drag and drop apple. So it has recognized apple. It has 100% confidence that it is the apple. Then I'll drop a mango. So also it has 100% confidence that it is a mango. And bananas. So sorry, it has 100% confidence it is for this single fruit. Suppose if I drop a say some other fruit like pomegranate. Okay, so it has a confidence that since we have trained for only 3 classes, it does not know what a pomegranate is. Okay, so it has 100%, 83% confidence that it is 83% pomegranate, and it is 16% mango. Okay, so this is the data it will return like probability. So if I put some other image, say orange, yeah, it has a 71% confidence that it's a mango, and 29% that it is an apple because of its shape and color. With the color, it is going towards mango, like it will be a mango. It will be, since if it is red, it will say like it is close to apple, like 70% apple and 29% mango, something like that. Okay, so this is how machine learning works. An output, like we can get this file, download this file, save this file as a ML model, and use in any of our iOS projects. Okay, you can just save it. It has downloaded, and okay, we'll go to Xcode now. Uh, how to use a similar file. Okay, so this is a model I have downloaded from the internet. This is the Google Place Internet. It's a very famous model. It is trained for 205 classes like this. And it also expects image as an input, and it will like return like about the scene, like what does it look like. Okay. So let me run this program. Okay, so this is the code I'm using for this. Um, so this is the machine ML model configuration object configuration, and this is the model, like this is the object of this class, Google Net Places. So when we drag and drop this class, this ML model, it automatically creates a class. All we do is just create a object of it, and to input, you're passing this image. It accepts image directly. Do not accept it. Accepts image as a buffer and the size with this size. So we are converting the image into buffer using this code. So it will return a buffer image. Then this we are passing this uh, buffer as an input to this object, and try call the function prediction function of the object with this input, and pass it to the output. So this output, it will return a label like what it is, like prediction label, like what it has predicted with this input object. Okay, so let's run it. Okay, so this is how it looks on a simulator. Like, now what I'm doing is I'm selecting an image. So this sees it this as a botanical garden, which is like somewhere close to that. Okay, what if I select this? Okay, it says it's a coast. So it's not exactly coast, but pretty close. So it depends on the number of data, like that you need to train a model to be perfect. So this is how machine learning works in core ML. Thank you. That's all